Welcome to A Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023, Paper 4, Variant 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 4 says, a heavy metal sphere of mass 0.81 kg is suspended from a string. The sphere is undergoing small oscillations from side to side as shown in figure 4.1. Mean this one is moving like this. So this is the oscillations of the sphere may be considered to be simple harmonic with amplitude 0.036 meters and period 3.0 seconds. For part A, state what is meant by simple harmonic motion. A typical question about simple harmonic motion, so you need to understand how to state simple harmonic motion. For simple harmonic motion, simply you need to understand condition for simple harmonic motion. Condition is A has to be equal to minus omega square x. Omega is angular frequency and this is constant. So we can say A is directly proportional to minus x. From here we can say A and x, they are directly proportional. So simply you can say A and x, they are directly proportional. X is the displacement. Directly proportional. So this is one thing you can say. A and x, they should be directly proportional to each other if motion is simple harmonic motion. So we can say this is one point. Now simply we need to state the significance of this minus sign. This minus sign is telling us opposite directions. Mean x and A, they have opposite directions. Mean when x is positive, A is negative. So let me write on here. When x is positive, it means A is negative. And when x is negative, it means A is positive. So this is significance of negative sign. So it means opposite direction. So we can say opposite direction. And if you write down these 2 points, you will get 2 marks. This question has 2 marks. So let me show you how you can write down the answer. In the answer, you can mention these points, these 2 points. You can say motion in which acceleration is directly proportional to displacement. So you will get 1 B mark, and the second one, acceleration is always in opposite direction to displacement. You will get 2nd mark. Part B says calculate the angular frequency of oscillations. The time period is given to us and value of time period is 3.0 seconds. We need to calculate angular frequency. Angular frequency simply is equal to 2 pi, the angular displacement divided by time taken. So if this angular displacement is equal to 2 pi, this one has to be time period. If this is pi, this has to be t by 2. So let me explain you a little bit about this one. Angular frequency is equal to angular displacement over time taken. If angular displacement is equal to pi, so the time taken will be half of the period, t by 2. So again you will get this will be 2 pi divided by t. So this is the angle covered divided by time taken. So this is the main idea. Now simply we can plug in values. We have 2 pi, this is divided by 3.0. So if we solve this one, we will get 2.1 radians per second. So this is the final answer. Second part says calculate the total energy of oscillations. And total energy of oscillations, this can be equal to the maximum value of kinetic energy, or this can be equal to the maximum value of EPE, elastic potential energy, EPE max. The easiest way to calculate total energy is simply we can write down this is equal to kinetic energy maximum, and kinetic energy maximum is 1/2 mv max square. You no need to remember the formula. If you follow these steps, it's very straightforward. So 1/2, here we have m, and v max for simple harmonic motion is Vmax is equal to A times omega. So simply we can replace Vmax with A times omega. A is the amplitude of oscillations. Now simply if we simplify this, what we will get 1/2 m, and here we will get A square times omega square. Now simply we need to plug in values. Value of mass is given to us in the question, that is equal to 0.81 kgs, and value of amplitude is also given to us, that is equal to 0.036 meters, and value of omega we have just calculated, that was equal to 2.1 radians per second. Now if we simplify, we will get in this case 2.3 times 10 to minus 3 joules. So this is total energy of oscillations, mean the maximum energy. So this is total energy of oscillations, and total energy of oscillations is equal to maximum kinetic energy, or EPE max. Means when the kinetic energy is maximum, EPE, this is equal to 0. You can also understand this one like this: total energy, this is the sum of kinetic energy at any displacement and EPE. So when this one is maximum, this will be 0, and vice versa is also true. Part C says the suspended sphere is now lowered into water. The sphere is given a sideways displacement of 0.036 meters from its equilibrium position and is then released at time t is equal to 0. The water causes the motion of the sphere to be critically damped. On figure 4.2, sketch the variation of the displacement x of the sphere from its equilibrium position with time from t is equal to 0 to t is equal to 6.0 seconds. Now the key point is that we need to understand, when oscillations are critically damped, what is the time taken? Time taken is about equal to one time period. So this is the key concept, is equal to about one time period. And in this case, we have already discussed that time period is equal to 3.0 seconds. And this is given to you in the question. Now, initial displacement is this. So it means it has to start from this point. And it will reach equilibrium position again when it is 3 seconds. So simply because it's time period, the time it will take to come back to equilibrium, that time taken is equal to one time period. Time taken to come back to equilibrium. It simply means that, let me explain you with one example. So imagine that this one is over pendulum. So this is pendulum and this is equilibrium position. We displace this one by displacement equal to 0.036. How long this will take to come from here to the equilibrium position? That time taken will be equal to one time period. So simply we need to sketch this one with decreasing gradient. So this is how you can sketch. After that, it will just stay here, so equilibrium. Then it has to be a horizontal line until here. So this is how you need to sketch. Let me show you the better one. If you want to look at a better one, so this one is a bit better. So this is how you need to sketch. So this is what question was asking us. Now let's try to understand a little bit more about this one. You can also look at these diagrams. So for better understanding, the green one, this one is critically damped. So this is critically damped. So you can see the time taken is about one time period. So this one, you see one oscillation. So it takes about one time period to come back to equilibrium position. And if you look at over damping, so this is over damping. This curve is representing over damping. It takes very long time to come back to equilibrium, more than one time period. And you can also see the red one. This is light damping. So the red one, this is representing light damping. So these are some important points you need to understand about these three different types of damping. Question 5 part A says define electric potential at a point. And this question is also typical question. You need to understand how to define electric potential. Electric potential, simply we can say, if I just write down here, electric potential. Electric potential simply is equal to the work done by external agent from infinity to a point. So simply we can say from infinity to a point per unit positive charge, per unit positive charge, unit positive charge. So this is how we can define electric potential. In fact, in physics, potential is not defined. What is defined in physics, that is potential difference. So that's the reason in this case we are also taking reference. So this is the potential difference between infinity and that point. So in physics, potential difference is defined, but potential is not defined. That's the reason we need to take a reference point. So it simply means that this is the amount of work done to bring a charge from infinity to a point. So we can also imagine this one. Imagine we have a charge Q and we place one little charge at infinity. So this is infinity. And we move this unit positive charge from this point to another point here. So the potential at this point is the amount of work done by external agent, because when we move this charge to the left, we have to apply force on this one to the left. So the work done by us is positive, and that work done per unit positive charge is the potential at this point. And so this is, we can imagine this one is the distance r. So this is, so if you move this charge from here to left, you have to do the positive work because you have to overcome repulsive force. And in this case, we also assume that initial velocity is 0. And when the charge reaches this point, final velocity is also 0. So we have to move this charge slowly. So the work done per unit positive charge to move charge from infinity to this point is the potential. So this is what is meant by potential. If this one is negative, so the work done has to be negative. So you have to move charge to the left, but you have to apply force to the right. So potential will be negative because work done by us, that work done is negative because displacement will be to the left and the force will be to the right, force applied by us. So the potential produced by negative charges is negative and potential produced by positive charges is positive. I hope this makes sense to you. If these videos are making sense and helping you to improve your understanding of physics, please like and subscribe and also share with your friends. Let me show you the answer, how you can write down your answer. In the answer, you can mention these points. You can simply say electric potential at a point is defined as the work done in bringing unit positive charge from infinity to the point. And if they ask you to define gravitational potential, so this is for potential. If they ask you to define gravitational potential, this is for electric potential. So if you need to define this one for gravitational potential, simply you need to replace. So gravitational potential will be equal to work done per unit mass from infinity to a point per unit mass. So simply you need to replace actually in this definition unit positive charge with unit mass. So simply this is what you need to replace. Rest is the same. Part B says two isolated charged metal spheres X and Y are situated near to each other in a vacuum with the centers a distance of 24 meters apart. Point P is at a variable distance x from the center of sphere X on the line joining the centers of the spheres. So it means this is sphere X. So here sphere X is located here. So we can say this is X and sphere Y is located here. So this is the first thing you can find out because the distance is changing from the center of the sphere. So it means that at the center of sphere X, X is equal to 0. This is how you can figure out. So this is X and this is center of sphere Y. Figure 5.1 shows the variation with x of the electric potential due to the spheres at point P. So this is the net potential. This curve is representing the net potential. Now first of all we can draw the spheres. So at this point, so this is over sphere y. We can also draw here, this one is sphere x. Now from here we can find out the radius. So the radius of this sphere is 4 and radius of this sphere is 2. The radius of sphere x is 2.0 centimeters, 2.0 meters actually, because this unit is meter. So you have to be careful with units. So this is meters. And radius of sphere y, this is equal to 4.0 meters. And the second thing we can say, the potential of this one is negative. Potential of sphere x is negative. This one is negative. It means x has negative charge, or we can say this is negatively charged. So x has negative charge. You can conclude from here. Vy, as we see Vy, this potential is positive, so we can say y has positive charge. So we can simply write down here y has positive charge. So these 4 points are very easy to write down, but question is asking you simply 3 points, 3 conclusions. So if you write down these 4 conclusions, you will get 3 marks. One thing more we can also conclude from here, at this point potential is equal to 0. It simply means that potential due to x at this point is equal to potential due to y, and potential is equal to k times q divided by r. And here we have, this is also k times q divided by r. In this case r is the same because this is the distance from the center of x and also the distance from the center of y. Distance is the same, so we can say r is the same. So r is the same, so we can simply cancel. R is the same. K is the same because this is constant, so it means the charge on x, the magnitude, is the same as the magnitude of charge on y. So this is also we can conclude from this. I hope these points make sense to you. Now let me show you the final answer, how you can write down your answer. In your answer you can mention these points. 3 of them you need to write down, but if you write down more it's better. So these points we can mention. So we have here 5 points. Let's try to do a little bit more practice about potential against distance graph and electric field against distance graph. These two graphs are very common in A2 physics from electric field topic. So you need to understand how to convert potential into electric field and electric field into potential. So here we have electric field, let's say this is in newtons per coulomb, and we have distance, this is in meters. You need to sketch the graph. You can try this one by yourself and then you can compare your answer with my answer. Let me give you the hint. Electric field is equal to negative dV by dx. Now if you look at dV by dx from this graph, so dV by dx is simply equal to the gradient of the graph. So it means we just need to look at the gradient of the graph. If you look at the gradient of the graph, here you can see the gradient. Gradient is positive, but before this one, this gradient is 0. So it means initially electric field is 0. So it means electric field inside the sphere is 0. So we will draw just horizontal line here. So this is here. Now you see gradient is positive, but you have to take the negative of that. So electric field is negative. And you can see gradient is always positive, means from this point to this point gradient is, first of all gradient is decreasing, so the electric field will be decreasing, then gradient is increasing but it is still positive. So it means electric field is negative between these two spheres. We can also understand this one in a different way, because this sphere, it has negative charge, so this has negative charge. So if I look at any point, let's say if I look at this point, electric field due to this one will be to the left, because this is negatively charged sphere and this sphere is positively charged. So electric field due to this one here, this electric field will be also to the left. So this is, so electric field anywhere between these two spheres is always pointing to the left, and by convention we take to the left is negative. So electric field throughout has to be negative. Now let me show you the answer, how you can sketch. So this is how you can sketch. So this is how you need to sketch the electric field. So you can see inside electric field is 0. So inside any solid metal sphere or hollow metal sphere, electric field is 0. And for thin non-conducting shell, if the charge is uniformly distributed at the surface, still electric field inside is 0. So here electric field is maximum, but it is negative, so you can say it is negative. Here electric field is minimum here at this point, so you can see this is minimum, and then it is increasing again, but it is still negative. And inside sphere Y, electric field is also 0. So this is how you need to sketch. Very good practice. Try this question again by yourself. And if you have any questions, leave your questions in comments. Part C says a positively charged particle is placed at point P in B such that x is equal to 12 meters. The particle is released. Describe and explain the subsequent motion of the particle. Pretty straightforward question, but conceptual question, and also a beautiful question to test your understanding of this topic. How we can answer this question? First of all, we need to understand at this point what is direction of electric field. We have already discussed that sphere Y, this sphere, this one is positively charged and this one is negatively charged. So this one is sphere X and then this one is negatively charged. So this one is positively charged, this one is negatively charged. So electric field due to positive, so this is our positive charge. So let me draw here. If we have a positive point charge, so this is positive charge, so the electric field will be pointing away from this one. So we are looking on this side, so electric field here, this is to the left. Electric field here, it will be upwards, and here it will be downwards at this point. And for the negative charge, so here we have negative charge, so this one is negative, so here we have negative charge. So if we draw the electric field due to negative charge, at this point it will be pointing to the left as well. So it means electric field here due to positive charge is to the left, and due to negative charge is also to the left. So this is direction of electric field. Now if we place positive charge at this point, positive charge, so positive charge will experience force in direction of electric field. So it means positive charge will just simply move this way. So this is direction of motion of positive charge. As in this case, along horizontal only electric force is acting. So electric force is the resultant force, and as resultant force is increasing, you can see the electric field, if we move this side, electric field is increasing. So it means that particle accelerate, but particle acceleration will increase. You can also understand this one from here. A is equal to F divided by M, and F is equal to EQ divided by M. Mass of particle is constant, charge on particle is constant. So if electric field is increasing, it means acceleration will increase. So few points you have to write down. First point, you will say particle will experience electric force to the left, and magnitude of electric force is increasing, so the acceleration of particle will increase and particle will move to the left. So these points simply you have to write down in your answer, and this question has 3 marks. If you write down these points, you will get 3 marks. So try to understand physics. Physics is something very beautiful. You need to feel the beauty of physics, beauty of thinking as a physicist. When you develop this way of thinking, you will see physics is very easy. So try to understand physics, and also please like and subscribe if these things are helping you. And if you need more help and you're looking for extra resources, please join Patreon. Now let me show you the answer, how you can write down the answer. This is how you can write down the answer, and in the answer you can mention these points. You can say particle is attracted to X and resultant force on particle is towards X. Particle accelerates and magnitude of acceleration is increasing. If you look at the last graph, when we sketch the graph between electric field and distance, you will see electric field at this point was maximum. So if we go this way, electric field is increasing, so it means that electric force is increasing. So this is how you need to answer.